This is another video in our Introduction to Physics series. We'll be looking at scalar quantities in this video. Again, I'm your host, Junior Roberts, coming to you with realjuniorroberts.com. Okay, so let's begin. Okay, so the first thing that we'll look at is for us to look at the objectives of this lesson. So our first objective is to define the term scalar quantities. Also, we'll be looking at giving some examples of scalar quantities, and also how to add scalar quantities. So first thing we'll actually ask ourselves is, what are scalar quantities? So a scalar quantity is any physical quantity that can be expressed completely as a magnitude or size only. Right, so what we're saying is that a scalar could be any quantity that once we associate with it a magnitude, we completely know what that quantity is all about. We actually have all the information required to understand what the quantity is referring to. And some examples of scalar quantities could include mass, time, and speed. So what we're saying is that, for example, a mass, let's say we have a 10 kilogram mass. So let's say we have a 10 kilogram mass, and because mass is a scalar quantity, right, this magnitude actually tells us all the information we need to know about this physical quantity here. So that is why we say that a scalar quantity can be expressed as a magnitude only, and it is completely expressed by just its magnitude, right? And again, some examples: mass, time, and speed. Okay, so let's talk about how to add scalar quantities. So sometimes we might have more than one scalar quantities interacting, and we need to find their combined effect. So for example, if we have a mass of 10 kilograms in a container, and we decide to place an additional 5 kilograms in that same container, the combined mass would be 15 kilograms. So here we see that to find the combined effect of scalar quantities, we can simply use the normal methods of arithmetics to find the sum of similar scalar quantities. So again, in the example before, where we had the 10 kilogram mass, we could have simply add the 5 kilogram mass, and then we'll get 15 kilograms, right? So we just use methods of simple arithmetics to find the combined effect of scalar quantities. So let's talk about some properties of scalar quantities. So in terms of magnitude, we already know that a scalar quantity has magnitude, right? In terms of its direction, it has no associated direction. And how scalar are added, we actually add them using normal methods of arithmetics or arithmetic. So let's look at some common scalar quantities and their units. So the first one we look at is mass, right? Its symbol is m, and its unit is the kilogram, right? Next one we look at is distance. Symbol can be represented as a d, and its unit is m, as in meters. Speed, symbol s, unit meters per second. Pressure, it's a capital P, and its unit is the Pascal. And then we'll also look at density. Its symbol is a common P or slant as forward pointing P. It looks more like this, right, called rho, and its unit is kilograms per meter cube. Right, so let's do a quick activity here. So here in this activity, we want to add 25 kilograms of aluminum and 12 kilograms of aluminum. So we'll take these two magnitudes of our two scalar quantities. Again, these quantities are actually mass, and we know from before that mass is a scalar quantity. So to add them, we'll just simply use normal methods of arithmetic. So we'll say 25 kilograms plus 12 kilograms. Right, so normally, so to add, we'll start with our ones column. So we'll say 5 plus 2 is 7, 1 plus 2 or 2 plus 1 is 3, and we'll keep our units. So this is how we'll simply add scalar quantities. We'll just use normal methods of arithmetics to find the combined effect of similar scalar quantities. So let's do a quick recap of what we have learned so far. So we've learned that scalar quantities are physical quantities that are completely expressed as a magnitude only. Another word for magnitude again is size. And some examples of scalar quantities include mass, time, and distance. And we can add scalar quantities using normal methods of arithmetic. So again, this was Junior Roberts coming to you with realjuniorroberts.com. If anything in this video was unclear to you, please post them in comments below, and I'll do my best to clarify any misconception for you. If this was helpful, consider sharing, hitting the like button, and subscribe so you're updated new videos like this. Thank you for watching.